Hello, I welcome you all in this lecture related with the subject materials processing, fundamentals and practical. And this will be the last the topic related with the metal forming related the approach of manufacturing. So, under the sheet metal forming in this particular presentation, I will talking about that how to utilize the metallic sheets effectively for making more products, which means how to increase the material utilization and reduce the scrap, so that we can produce the more component out of the given sheet stock material. This in turn helps in reducing the cost and increasing the material efficiency which is being used. So, a stock layout is basically related with the identifying how the material should be cut from the stock metallic sheets, so that we can produce more products out of the given material in such a way that the maximum amount of the units can be produced from a given stock material. So, initially we will be talking about the need, then what is the importance, because the stock layout affects lot of aspects, like it may be not just the utilization which is indicating the yield, like how much things are being produced from a given material, or scrap. So, these are the two similar kind of things which is indicating how effectively material is being used. But this is not just this aspect, but it also affects the die design, okay, and whatever depending upon the complexity or simplicity of the die, it will affect the cost of the die. Similarly, it will affect the kind of press to be used, okay, the kind of the production volume or the production rate that can be realized, okay, and the flow of the material during the processing. So, there are multiple aspects that will be affected by the way by which is stock layout is developed for making the blanks and the products from a given stock. So, in this presentation we will try to see how to what are the different strategies related with the stock layout, primarily to increase the material utilization, reduce the scrap and achieve all these benefits, so that the product can be made at low cost with the greater material efficiency, and what are the various factors that will be affecting a stock layout, all that will be covered in this presentation. So, let us say we have got a sheet like this, okay, this is a very long sheet. So, this sheet may be in form of a strip or it may be in form of coil. Coil, if it is very long, then continuously material is taken from the coil for processing. So, it can be sheet metal can be in form of the strip or coil. Okay. This is one aspect. So, for high volume production we use coils, and for limited volume production, especially in case of thin sheets, we use strips. Okay. This is for low volume thing, and the coils are used primarily in case of the thin sheets. In thick sheets we have to use a strip in any case. So, say this is the scenario, we have got a one sheet metal now. So, in simple shapes what we do, we just make a cut like this. If the width of the component is matching with the width of the strip, then we will make a simply cut like this. So, one cut, another cut, another cut. So, this is called cut off, okay, sheet metal operation, and this will be resulting the maximum efficiency. But if the shape is not so simple, but the shapes are little complex, if they are not, but if it is like this, okay. So, if the shapes are having different angle, then there will be one part, this is one part, second part, third part, fourth part, but whatever is the material in the beginning and at the end, that will not be used for any purpose. So, this will be there as a scrap, this will be left out as a scrap, okay. And this scrap is simply waste of material, okay. And if the shape is further complicated, like the shape is like circular blanks are to be produced like this, then the circular blanks offer the maximum scrap and minimum material utilization. So, we have to identify how to arrange the cut profiles and how many cuts will be made in a strip, so that we are able to produce maximum number of products from a given volume of the metal, in order to increase the material utilization and reduce scrap. This is one of the main ideas, okay, behind the layout design, apart from other aspects like how complex or how simple die design will be there, what is the press capacity available, in which direction, what will be the direction where from the samples will be cut, what will be the direction of burr, what kind of the stock material is being used. So, there are multiple aspects. So, stock layout is basically related with the identification how the samples or the blanks will be cut from the stock, so that the maximum number of the items produced. Okay. So, stock layout, what it is, in blanking operation, stock layout consists of a drawing showing how the blanks will be cut from the sheet. So, if this is the sheet, and if the shape of the stock is shape of the blank is like this, then on the sheet we have to make the drawings first like this, and accordingly the die will be developed either for making a single cut or all these multiple cuts in one go. Okay. So, it can be single or more than one, no, more than one cut can be made. So, once the stock layout is identified, then the die will be designed accordingly. Okay. So, in the blanking operation, stock layout primarily consists of the drawing showing that how the blanks will be cut. If it is simple square shape, then like rectangular shape, then we will be showing in the sheet like this lines where from cut will be made and the die. So, the cut dies will be used accordingly. Stock layout can be drawn when the blank shape is known. If the blank shape is not known, then like say the blanks may be processed further. Say the blank is like this, and out of this we have to make a particular product of a particular shape, then this will be further processed, but in that case it will be resulting in lot of scrap. So, the stock layout can be drawn when the blank shape is known. If it is not, then we have to make the strips for in form of blanks for further processing. In case of multi-station sheet metal operations, the stock layout shows the operations and their sequence, shows the two things, operations and their sequence to be performed in the sheet metal, especially in case of the progressive and transfer dies. So, lot of operations will be performed in sequence like this. So, which operation will be done first, which second, and that will be, and in which way it will be done, like what kind of the cut will be made, whether it will be a simple hole first, then blanking, then parting off like this. So, in what are the different operations that will be performed, and what will be the sequence of operations, that is identified very much in the beginning, especially when we are using the progressive or transfer dies, where multiple operations will be performed either one or at different stations. So, that is what is done in case of the multi station sheet metal operation. Stock layout shows the operations and their sequence. What is the need? As I have said, stock layout in blanking operation, designing of layout of metal cutting profile such that maximum amount of the sheet is used. And when we have that situation, that it is designed in such a way that the maximum amount of the sheet is used for making the blanks, then the percentage of the metal actually being used for producing the blank, that is known as yield. So, we have say out of the stock of area A, if say this is the B, that is the blank which is produced, then the remaining C outside, that will be there as a scrap. So, if you want to determine the utilization percentage, then B by A will simply give us the percentage of that utilized percentage utilization, that also is termed as yield in terms of the percentage. But if you want to determine the scrap, then simply A minus B divided by A percentage will give the scrap percentage. So, what material is being used, that will be giving us the yield or the utilization percentage, and the balance will be there as a scrap. So, idea behind the designing a stock layout is to increase the yield and reduce the scrap, so that our material efficiency can be enhanced and more can be produced from the given volume of the sheet metal. So, in sequence of operations, how it is done: for simple cutting dies, processing route is prepared at the time of a stock layout, that is not a very big deal. Mostly blanking operation is done first, okay, and then blanks are then made, then fed into the dies for other operations like punching, notching, forming, and the drawing. So, initially what will be done, we will making the blanks like this, 3 blanks, and these will be fed further for the sequencing for further operations down the for further processing to make the products. What is the importance? As I have said, there are multiple aspects which depend on the stock layout. Stock layouts are drawn accurately on the individual sheets in its, as it forms the basis for die design. So, the design of the die is one of the aspects that depend on the stock layout being designed and identified, and designers may trace the die drawing from the layout. So, this can form the basis, this forms the basis for the die design. It is usually not drawn by the die designer, but by someone else, but designer must be familiar with the stock layouts, like what it is and what is its importance. Then developing a stock layout needs the knowledge of the press also, because if the die is designed in such a way that it cannot be accommodated in the press, or the press does not have the desired capacity, then despite of having the good die, you may not be able to process the components. So, a stock layout to some extent therefore affects the die design. So, there are multiple factors which affect the stock layout, or like how the material will be cut from the sheets for producing the blanks and the products. That depends on the multiple aspect, but the first and foremost parameter is the scrap percentage or the material utilization. Efforts are always made in such a way that the stock layout is developed in such a way that the scrap percentage is minimum, but it depends on again the type, the form of the sheet metal, whether sheet metal is in form of a strip or the sheet metal is in coiled form, that is particularly in case of the lengthy high volume productions, the coiled stock is also used. Then the direction of fibers, we know that most of the steel strips are produced through the rolling process, and in the rolling the grains are elongated in a particular directions. Okay. So, it may be required that when the deformation is carried out for sheet metal processing, then it is required for maximum strength, it is required that bending is done in the direction 90° in the direction perpendicular to the direction of the fibers for gaining the maximum strength. So, whenever any condition is imposed for restricting the stock layout approach, then that will simply be increasing the scrap or reducing the material efficiency. So, this is one aspect, like if there is any limitation or a condition like how the stock layout should be developed with regard to the direction of fiber, then that will simply limit the material utilization, reduce the material utilization and increase the scrap. The direction of burrs, mostly the burrs are produced at one end. So, we have to see if which side the burr should be produced. So, sometimes producing the burrs in a specific direction also limits the stock layouting, and that in turn affects the scrap. Press design is important. We have to see that the sheet metal of given thickness can be processed by given capacity of the press or given dimensions of the press using the die which will be developed based on the stock layout. So, for developing the stock layout, we have to see that whatever die is developed, that is accommodated on the press in terms of the tonnage and also in terms of the bed area. Then the production volume, depending upon the production volume requirements, we have to see like whether we will be using the stock layout or the strip, we will be using the coiled strips or coiled stock or the strips, or these are thin or thick. Accordingly, the layouting stock layout is developed. Then it is the die cost is the, of course, it is very important aspect, because for more accurate strips, for complicated shapes of the blanks, for more accurate blanks, the dies are costlier as compared to the simple shapes and somewhat less accurate. So, there are multiple factors that will be affecting the die cost, and which are based on the stock layout. So, the scrap is one of the first and foremost factor, that scrap is one of the most important factors that is used as a basis for stock layout. Okay, major factor in making a stock layout, because focus is there on reducing the scrap to the minimum level. Reducing the scrap reduces the material cost per blank, which in turn reduces the product cost. Okay, that is why it is important. So, utilization is also used as a complement of the scrap. Reducing the scrap increases the utilization, and utilization percentage is also referred as a yield. So, here we can see whatever is the percentage utilization, say 70, and then remaining 30 will be the scrap. So, their sum will be 100. Okay. So, nesting, this is one variant of the stock layout. Nesting of a blank is a method of to reduce the scrap, like say here we have the stock material. So, how the cut profile will be made? So, this cut profile is known as nesting. Okay. So, the nesting of blanks is method to reduce the scrap. Okay. Nesting may also be termed as a fitting of the blanks, so that they occupy minimum space. Say this is the space available. So, how will be fitting the blanks to be produced in this the sheet metal, so that we can produce more number of blanks out of the given material. And this will initially this will be made on the with the help of paper and pencil, to see like how this fitting can be developed, what will be the orientation of the cutting, so that the maximum number of the blanks can be produced. Therefore, processing of a stock layout is called stock nesting. Like if we see, if the blank is to be cut in a particular simple shape, say rectangular shape. So, the blank, say the blank width dictates the width of the sheet metal to be used. So, we will be using the strip or coiled stock in such a way that the width of the strip is equal to the width of the blank to be produced. Width of the blank, width of the strip or the sheet is equal to the width of the blank. So, this dimension is now fixed. Now, another dimension for another dimension we will be doing simply identifying where from cut will be made. Okay. So, those cut lines will be made. When a cut line is made in such a way that it results in the minimum scrap, say if this 1, 2, 3, 4, then this will be the wastage, this will be the scrap. But if the cut length is identified in such a way that we are able to produce more number of the blanks out of a given metal, then that will be resulting in the maximum utilization. So, it is possible in this case it will be resulting in the maximum number of, like say like this. So, 1, 2, 3, 4, 5, 6, 7, 8. So, entire strip has been used for producing the blanks, and there is no scrap. But if the product shape or the blank shape is a little different, like it is not like rectangular, but it is having some parabolic shape, sorry, some angle, in that case the material in the beginning and at the end will be left as a scrap, and will be able to produce 1, 2, 3, 4 blanks, while the material at the in the beginning and at the end, leading and trailing edge, will be wastage. So, this is the say leading edge, and this will be the trailing edge. So, material from the leading and trailing edge will be wasted. So, theoretically, for the rectangular and square shaped blanks, the cut off dies result in the zero scrap, but for other products it may result the minimum scrap and the maximum utilization. Okay. So, nesting for cut off dies, how it is done. Designing stock layout for cut off dies is ideal, because it results in the minimum wastage and minimum scrap, maximum yield and utilization. leading and trailing edges must nest perfectly for such dies. Say, so that is why the leading and trailing edge if these are also accommodated as a part of the blank, then that will result in the maximum utilization. Say this is the, say, coiled stock, so one blank, another, unlike this, cutting can be done continuously and this will result in the minimum wastage. But if it is not so, then if this is the kind of product to be made, then we will be having one blank, another blank, and this is how it will be continued. So this initially in the leading edge will be having some scrap, but if we consider in case of the coiled stocks, this percentage will be negligible, or it will be very less, okay, nearly 0% scrap and nearly 100% utilization. In this case, in the first case, it is the 100% utilization. Okay. So, width of the stock determines the one dimension in this case, else it will prevent the cut off arrangement for producing the more accurate blanks. So, means we will be selecting the width of the strip in such a way that it is corresponding to the width of the blank which is to be produced. So, this is another example of the cut off dies where the 100% utilization is realized and 0% scrap is done. So, cut off the die nesting for cut off dies result in the maximum material utilization and minimum scrap percentage. But for the round blanks, it is just opposite. Blanking dies for round blanks is an example of the poor nesting. Okay. The stock layout for the round blanks therefore offers the lowest percentage utilization for all blanks amongst the all blank shapes, and the how utilization percentage can be increased by having the two or more rows. So, when we are having like say one strip like this and a single row is being used, then remaining skeleton material will be left as a scrap. Okay, and this will be resulting in the lowest percentage utilization. But when we use little wider strip and then one row, second row is used, then we get lot of little bit material saving and the material utilization percentage enhanced. But when you go with the third one, this material saving is further enhanced. The idea here is, let us identify the how the round blacks should be cut from the given stock material, so that our material utilization can be enhanced and the scrap can be minimized. Say nesting for the odd shape contours. So, if we do simply the nesting in this particular way, then this will be resulting in, this is called like before tipping. If we do not give any inclination for making the products while cutting, then like this is the before cutting, this will be resulting in the more scrap and less utilization. Okay, reduced utilization. But if the blanking is done by tipping it at some angle, okay, by inclining the blanking at some angle, then this will result in the material shaving, okay, and this will increase the percentage utilization, okay, and reduce the scrap. So, in case of odd shape contours, in such cases edges that have approximately same contours are matched. Okay, this is one. And then there are certain guidelines how it can be done. This can be done using the various arrangements like tipping the blanks at an angle like this, or turn the blanks upside down, like this is one arrangement. Okay, this will be causing much more wastage of the material and more scrap, less utilization. But if the turning is done upside down, turning upside down like this, then one blank, another blank, another blank, then the shapes of the blank is different, but how it is being cut, that is a different. So, we may use the two cuts in one pass, okay, for making this kind of arrangement. Then this is another shape before turning and the after turning, means upside down arrangement. So, this will be causing much more saving, like this is the saving when we do the turning upside down, then this will be causing, leading to the more significant saving of the material. So, arranging the turning blanks upside down and rounds turning blanks upside down, or tipping blanks at an angle, arranging different shape blanks but of the same thickness and material, say If we are dealing with the variety of the blanks which are to be produced and still some material is left, then it is possible like we can produce one blank from this location, one blank from this location. So, left out material can also be used for making the additional the blanks for some other purpose, but this kind of, so different shape blanks can also be produced from the left out material, or these can also, this thing can also be included in the die design approach. So, when blank of one shape is being produced, the blank of other shapes are also being produced, but the condition is that the thickness of the another blank to be produced is same and material is also same. Then we can combine the blanks of the different shapes in stock layout and the die can be designed accordingly. Okay. So, these are the few technical terms which are used in the stock layout, like say A is the area of the uncut sheet, B is the area of the blank produced, then utilization is obtained from the B by A into 100 and scrap is obtained from the A minus B divided by A into 100. And in case of the complex shapes, B calculation becomes difficult. So, we have indirect method of calculating that, like in that, if in case of complex shapes where B means that the blank area is not cannot be calculated so easily, then in that case the approach which is used to determine the area being used per blank, that will be indicating the percentage utilization. Area used per blank is like progression, area of the stock being used for producing per blank. So, progression into width divided by the number of blanks. So, in that case what we do basically say number of blanks from the width and the given progression. So, what is progression? That is the spacing. In this particular case, this is the progression and then this is the spacing. Okay. So, the progression successively between the two the stocks. Okay. This is the progression. So, progression multiplied by width will be giving the area used per blank to the number of the blanks. Therefore, stock width, progression and number of blanks considered in the progression used to obtain the area of sheet for obtaining the obtaining area of sheet metal for obtaining per blank. Okay. Spacing, as we have seen, is the another factor that affect the percentage utilization. There are number of factors that affect the spacing, like say this is the sheet metal. So, how much space is to be left at the corners and between, say this is 1 and between the two blanks what should be the space left. Okay. So, this space at all these corners and between the blanks also, like this space between the blanks. Okay. This space, the gap between the corners and the between the blanks, that is known as a spacing, and this spacing must be greater than 1.5 times of the sheet thickness. Okay. If it is not done in that way, then it will be leading to the deformation of the edges and the roughness of the edge. The cut blanks will be very poor. So, in order to ensure the any kind of the damage to the edges of the blanks being produced, or to have the accurate and the good surface finish, the spacing between the blanks and spacing of the cut edge from the corners, that has to be maintained. Say this is the blank, then this spacing between the cut edge and the strip edge, this has to be maintained. Okay. So, and spacing is another factor affecting the utilization percentage. Okay. Is the spacing between the blanks. No spacing in case of the cut off die. We have seen that cut off die simply cut is made, but in case of the blanking where nesting is done and the spacing between the blank edge and the edge of the stock or edges of the blank. So, that is important. Minimum spacing should be 1.5 times of the sheet thickness. Okay. And this spacing can be greater also for the softer metals and for thinner metals, because they will show greater tendency of that of getting damaged. So, less spacing promotes the slip, dull cut edges, rough edges. So, for soft metal more spacing, for thinner metals we need more spacing. Form of strip, form of the sheet metal like strip or coiled sheet metal, this is another major factor, because this will be affecting how the sheet metal will be fed into the die, whether it will be fed just in once or it will be fed, it can be fed multiple times. So, if it is the strip, we can feed the strip in the die multiple times as per the number of blanks to be produced, okay, from the given strip. But in case of the coiled strip, it is just one go. So, the form of strip is crucial in stock layout design and design of the die accordingly. This is the another major factor in designing of the stock layout, whether it is we have to use the sheet metal in form of strips or coiled stocks. Strip stock can be fed Strip stock can be fed through the die multiple times, more than one. Coiled stocks are generally fed through the die only once. Okay, recoiling is usually not done because it's expensive. Not just expensive, but also it weakens the cut material, because once we will be making the cut and then recoiling it and doing it again, that is not really very good idea, because material gets weakened and there will be potential for damage to the surface of sheet metal. Therefore, coiled stocks is preferred only for the high volume production, especially in case of the little thicker sheets, and stock needs to be passed through the die once only. Direction of fiber, as I said, so the rolled sheets will have the grains oriented in particular direction, and the direction of the grains that will be showing the greater strength. So, if there is any specific preference with regard to the stock layouting and further processing of the product later on, if we impose that kind of condition, then the stock layouting must be done in that way. That has to be kept in mind, that the blanks are produced from the particular direction of the strip. Okay. The sheet metal shows greater strength in the direction of fiber, strip length, or the rolling direction. For maximum strength, for the maximum strength from the bent part, bend should be made across the strip or at 90 degree angle to the fiber. So, if bending is to be done, then bending in direction perpendicular to that of the fiber or the grains, that gives the maximum strength. So, in such cases, the blank cannot be tipped or rotated not to just any position desired, but this limits the orientation and direction where from the blanking will be done. So, this specific requirement may result in the higher scrap due to the limited nesting of the blanks. Therefore, fiber direction requirement for a stock layout should be mentioned only if it is absolutely necessary, otherwise this will simply increase the material wastage, it will increase the scrap and reduce the material utilization. Direction of burr is another thing, like when the cut is made, we find it like this. Okay. So, this is the burr which is produced, then disc shape and then fracture zone. So, the burr, which side burr should be there, that is important. So, and that may, if that is important, then it has to be mentioned, like which side burr is to be produced. On cutting sheet metal, a burr is produced on punch steel side of blanks and die steel side of the whole or skeleton. So, some parts it may be required that burrs to be have on a specific side. If that is the case, then that has to be mentioned. For example, burrs on the hidden side need to not to be removed necessarily, as it increases the cost. Mentioning the, in that case we have to mention that the burrs on the downside, if we mention, then this will limit like how the nesting or the stock layout will be developed, so that the burrs go inside. Okay. Control of position of the burr on a specific side may limit the stock layout arrangement, and which may limit the material utilization. Okay. So, if we mention any specific condition regarding the guideline or direction where from and how the stock layout should be developed, so that the blanks are produced according to the requirement, then that can be done, but it will reduce the material utilization and increase the scrap. Okay. Higher burrs are produced on cutting of the soft metal using the dull cutting edges. The press is another aspect, you see. So, we have to see that whatever stock layout is developed, that is that accordingly the die is made, and the allowed dies, and whatever the die has been designed, the press is able to handle that. So, we have to develop the stock layout. Okay. First, accordingly the die is designed, and whatever die is designed, the press must accommodate that, and that in terms of the area of the bed and tonnage of the press. So, whatever the stock layout has been developed, that must be executed with the help of suitable available press. So, press also is to be kept in mind while developing the stock layout. That is the idea behind this, because stock layout can be affected but due to the availability of the press bed in terms of the bed area and the press tonnage. The volume of the production and the thickness, these are the two very important aspects. Say if we are dealing with the low volume and thin sheets, then strip stock is to be used with a single pass layout and die cutting one or more blanks at a time. Low volume thick sheets for stock strip stock is used, okay, a single or double pass layout and the die cutting one blank at a time. For higher volume production, thin sheets, coiled stock is used and a single pass layout. In die cutting, one or more than one blanks at a time. For high volume production, strip stock is thick sheets, strip stock is used, single or double pass layout and die cutting more than one blank at a time. Okay. The die cost is the last factor related with the stock layout, which can affect the stock layout. Why? Because if we make a simple stock layout, our die design will be simple, die cost will be less. If our if the blank shape is complicated, die shape will be complicated, that die will be costlier. If you want more accurate blanking, then our die has to be there accordingly and the die cost will be more. So, these are the various factors. Die cost may be higher for high volume production because it has to be more robust, made accordingly with a good quality material. Cutting more than one results in the higher die cost. Double pass dies are cheaper than the cutting two at a time. Extremely complicated blank shapes, cutting more than one results in the costlier die. In case of extremely accurate blanking, cutting more than one result in the costlier die, and therefore, simple round and square shapes with the multiple cutting at a time is more practical approach of the stock layout for producing the blanks. So, here we have seen, so now I will summarize this presentation. In this presentation, basically I have talked about the stock layout, what it is, what is its importance, and how by using the different approaches we can increase the material utilization, reduce the scrap, increase the material efficiency, reduce the cost of product. What are the various factors that should be kept in mind while designing the stock layout? Thank you for your attention.